Hello, everyone. This is yet another lecture of chemistry NCERT where we will be discussing aldehydes, ketones, and carboxylic acids. And in this particular video, we'll be completing every single line of the NCERT, besides some of the extra things that maybe we might need a little more depth. And this is just going to be a revision, so make sure you're done with your basics and say you don't want to go through the book, pick your book up, and like you're too lazy for that. So you can just take a nap and just listen to the video, and I think you will be pretty much done. And this can actually be helpful for your need for your competitive exams, which are all about NCRT these days, and also your boards. So, without further ado, let's just get started. Um, in the previous unit, you have studied organic compounds with functional groups containing carbon oxygen single bond. In this unit, we will study about the organic compounds containing carbon oxygen double bond, that is the carbonyl group, which is one of the most important functional groups in organic chemistry. In aldehydes, the carbonyl group is bonded to a carbon and hydrogen, while in the ketones, it is bonded to two carbon atoms. I think this paragraph is more or less about these pictures that are given over here. It will just tell you just the basics. It says that we've already done, like in alcohol phenol ether, we did carbon oxygen single bond, but like in this lesson, we'll be discussing categories of compounds which would contain a carbonyl group, which is basically the C double bond O group. And is trying to say that we have an aldehyde, say this is going to be the constant group over here. Fine, you will have a carbonyl group. Now if it's attached to an alkyl and hydrogen, then it'll be an aldehyde. Beech mein hai dono taraf se it'll have alkyl, then it'll be a ketone. Say it has an alkyl group ek taraf se, dusri taraf you'll have OH moiety. This is a carboxylic acid, which we'll be discussing in actually details. Then you have an acyl halide, say you have a halogen atom, then you have amides, NH2 amine group attached to this constant moiety. Find the carbonyl group. And all of these will be discussed in the lesson. So now that we're not even missing out a line, we'll still read this paragraph. The carbonyl compounds in which carbon of carbonyl group is bonded to carbon or hydrogen and oxygen of hydroxyl moiety are known as carboxylic acids, while in compounds where carbon is attached to carbon or hydrogen and nitrogen of NH2 moiety or two halogens are called amides and acyl halides, respectively. Esters and anhydrides, again, something that we pretty much missed. It's here where you have the esters and the acid anhydrides. You can actually see you have if you have an OR dash group attached, and acid anhydride basically we get by dehydrating. If you take two carboxylic acids, we'll take out the water molecule out and you'll get an acid anhydride. Actually, self-explanatory term hai. So you can understand. We will still go through it in detail when we read further. Now you have another paragraph again telling you about the complementary details of like the basic uses of aldehydes, ketones, carboxylic acid, basically the compounds containing C double bond O group. How are they useful? Just to add little more details, say they play an important role in biochemical processes of life. They add fragrance and flavor in nature. Fragrance ke to pe they have given vanillin, vanilla वगैरह वाला flavor. And then the salicylic, say if you had COOH group instead of this CHO group, then it would have been salicylic acid, which again we'll be discussing in the lesson. You have cinnamaldehyde, just remember the structures um, superficially. Then from meadowsweet, the salicylic vanillin from vanilla beans, and cinnamaldehyde from cinnamon have very pleasant fragrances. They use so of course for their aroma and in many food products and pharmaceuticals to add flavors. Fine. Some of these families are manufactured for use as solvents, that is acetone, and for preparing materials like adhesives, paints, resins, perfumes, plastics, fabrics, etc. So the very basic uses. Now, getting on to the actual lesson nomenclature and structure of the carbonyl group. Let's actually go into the depth of this carbonyl group that we'll be discussing in this lesson in a lot more detail. Aldehydes and ketones. About the nomenclature, we already know. We might have, some of you might have actually done the in GOC, of course. We have the IUPAC, and we know how do we name different functional groups. But before that, coming to the common names, which can also be asked, so aldehydes and ketones are often called by their common names instead of the IUPAC names. The common names of most aldehydes are derived from the common names of the corresponding carboxylic acids. You have to remember, aldehydes ka naam carboxylic acid se hi aayega. How, just like you'll consider them to be a substituent of the carboxylic acids only by replacing the ending ic of the acid with the aldehyde. So you have acetic acid over here replacing the IC by aldehyde, so you'll get acetaldehyde. Then at the same time, the names reflect the Latin or Greek term for the original source of the acid or aldehyde. The location of the substituent in the carbon chain is indicated by Greek letters alpha, beta, gamma, delta, etc. The alpha carbon being the one directly attached to the aldehyde group. Fine. Beta carbon the next, and so on. For example, see over here what this paragraph is trying to say is basically हम लिखते हैं aldehyde को as derivatives of carboxylic acid. अब जो हमारा common name carboxylic acid में है उसी के लास्ट पे हमें हमें पता है acetaldehyde is come from acetone. You'll also know the Greek origin because acetone is a Greek term. It's a common name. Again, for numerals, we don't use 1, 2, 3, 4 just like in IUPAC. We use alpha, beta, gamma, delta, etc. This is something really easy. So I think we can just move on. यहाँ पे कुछ एग्जांपल्स दिए हैं बेंजिल्डिहाइड जहाँ पे आपने बेंजीन के ऊपर you will have the aldehyde group. Then you will have gamma, beta bromobutyryl dehyde. Fine again. You have butane chain, you have four carbons, you have this aldehyde group. On the beta position, you have bromine. Fine. Then you have the common names of ketones. About ketones, they're derived by naming two alkyl or aryl groups bonded to the carbonyl group. Now we know in case of your ketones, you'll have the carbonyl group दोनों तरफ से it'll be having an alkyl group on both the sides. So we'll name it on the basis of the alkyl groups attached. The locations of substituents again by Greek letters because we are discussing common name system. This won't be now just alpha beta, it'll be in pairs because you'll have two alkyl group. So you can have alpha alpha dash position, beta beta dash, and so on, beginning with the carbon atoms next to the carbonyl group indicated as alpha alpha dash. So the first carbon attached to the carbonyl group will be named as the alpha group. And this is, I think, something which is quite conventional. Some ketones have historical common names. The simplest dimethyl ketone is the acetone. So this is something very historic. Alkyl phenyl ketones are usually named by adding the name of acyl group as prefix to the word phenone. So if you have एक तरफ से आपका phenone group होगा, दूसरी तरफ से आपका alkyl group होगा, बीच में फंसा हुआ हमारा ketone है. Like always, it's something that is not terminal in nature. This is our carbonyl group in case of a ketone. So we will take it phenone है बीच में and we'll have acetophenone because based upon कौन सा alkyl group हमारे यहाँ पे attached है. Similarly यहाँ पे you'll have propane group, fine, then you'll have propiophenone. Similarly यहाँ पे benzene ही पूरा attached है, so you'll have benzophenone. Coming to now the more important one, the IUPAC nomenclature. The IUPAC names of common chain aliphatic aldehydes and ketones are derived from the names of the corresponding alkanes by replacing the ending e with al and on respectively. I think we have done this already. We'll take basically hamara longest chain as the parent carbon chain, the root word, right? And uspe we'll see numbering will be done according to where the substituent or wherever the functional group is placed. Alkane will be the major name जो हम root word जहाँ से निकालते हैं अपना, and that the e will be ending e will be replaced by al and on respectively in case of aldehyde ketone. So in case of aldehydes, the longest carbon chain is numbered starting from the carbon of the aldehyde group, while in case of ketones, numbering begins from the nearer to the carbonyl group. The substituents are prefixed in alphabetical order along with numerals. Again, numerals, not alpha, beta, gamma, indicating the positions of the हमारे जो भी substituents हैं उनकी positions indicate करने के लिए we will be having our numerals. Fine. The same applies to cyclic ketones. So you have cyclic कुछ आ जाते हैं, ठीक है, where the carbonyl carbon is numbered 1. Always when the aldehyde group is attached to a ring, the suffix carbaldehyde is added after the full name of the cycloalkane. पहले हम हमारा cycloalkane का नाम लिखेंगे. You have cyclohexane over here. उसके बाद हम इसका will add a suffix that will be carbaldehyde. Clear? So this numbering of the ring carbon atom starts from the carbon atom attached to the aldehyde group. This is where we'll be starting from. ये जो attached है. All right. The name of the simplest aromatic aldehyde carrying the aldehyde group on a benzene ring is benzene carbaldehyde. Fine. So, however, the common name benzaldehyde is also accepted. So, benzene carbaldehyde, benzene will be the parent chain जो हमारा benzene ring होगा. उसके बाद carbaldehyde का हमने suffix लगाया है, which means aldehyde group attach होगा. और benzaldehyde भी benzene carbaldehyde को बोला जाता है. It's also accepted IUPAC से, though it is a common name. Other aromatic aldehydes are hence named as substituted benzaldehyde. बाकी aromatic को कैसे करते हैं? हम लेते हैं as say the main thing will be the benzene और उसी का substitute हमारे different derivatives of benzaldehydes आते हैं. So, consequently, there are a lot of examples given over here. You will have ethanol is given. Then, of course, starting from the carbon atom attached to the carbonyl group directly. Actually, this carbon will be starting with. Then you'll have one, two, three. 3 पे मिथाइल आएगा, 4 पे ब्रोमो आएगा. But again, 4 ब्रोमो से स्टार्ट करेंगे बिकॉज ब्रोमीन का जो है अल्फाबेटिकली ब्रोमीन पहले आएगा. फाइन. देन यूल हैव अगेन द साइक्लोपेंटेनोन 3 मिथाइल. फाइन. 3 पोजीशन पे मिथाइल है. And similarly pen 2 enol. Why 2 en? Because at the second position you'll be having the double bond. Fine. Next up we have this again. Again you'll have one phenyl being the substituent. Fine. Propane 1 on. At the first position you'll have the ketone group. Again some more examples. You'll have 3 oxo over here. Why? Because again this is about the priority list. Say aldehydes will be um, more prior, so we'll take them to be the uh, basically the functional group, and the ketone group present here will be taken as the substituent. So substituent jab bhi ketone lete hain, what is the prefix we use? It's oxo, and since it's at 3 position 3 oxo pentanol. Similarly you have 2,4 dimethyl pentane 3 one. Again this will be the longest chain. Similarly over here you have 4 nitro benzene कार्बल्डिहाइड. अगेन बेंजीन है तो बेंजीन का डेरिवेटिव आएगा. कार्बल्डिहाइड हम सफिक्स लगाते हैं. बेंजीन हमारा मेन चेन होगा. एंड 4 नाइट्रो बिकॉज 4 नाइट्रो नीचे हमारे पास it's like a substituent. And benzene carbaldehyde can also be replaced by benzaldehyde. We also know that. Then you have propane 1, 2, 3 tricarbaldehyde. Again, this is the parent chain. It has 3 different aldehyde groups attached over here. All right, 1, 2, 3 tricarbaldehyde. Now here you have some more this tables given about the structure, the common name, and the IUPAC name. See for this you have formaldehyde, IUPAC में methanol बोलते हैं, acetaldehyde को ethanol बोलते हैं. Some of them are actually important. Fine. Then you have isobutyraldehyde, 2-methyl propanol, isoneo. These we use in common name terminology, right? So gamma methyl cyclohexane carbaldehyde, again 3-methyl cyclohexane carbaldehyde. Once you take your pen and actually do these examples, I think it's way too easy. Just reading them won't work. Then acrolein, propanol, and similarly all of the mesetyl oxide, right? Mesitylene will be going through again in a few lectures. Now, moving on, getting on to the structure of the carbonyl group. C double bond O. Fine. C double bond O, one is sigma, another is pi, right? This is something we know already. The carbonyl atom is sp2 hybridized, right? ये जो carbon है ये sp2 है, y double bond है, fine, and it forms 3 sigma bonds, right? 3 sigma. The fourth valence electron of carbon remains in its p orbital and forms a pi bond with oxygen by overlap with p orbital of an oxygen. Fine, there'll be a p pi overlap of carbon p orbital and oxygen का p orbital, and they'll form parallel overlap में ऐसे they will be forming a pi bond. Fine. बाकी कार्बन के 4 वैलेंसीज है तो 3 उनमें से हाइब्रिडाइज हुए हैं. इसकी हाइब्रिडाइजेशन sp2 होगी. In addition, the oxygen atom has 2 non-bonding electron pairs. Do we know about this? Obviously, electron pairs, lone pairs are present on the oxygen atom. Thus, the carbonyl carbon and the 3 atoms attached to it lie in the same plane, and the pi electron cloud is above and below this plane. The bond angles are approximately 120 degree as expected of a trigonal coplanar structure. Over here, हमें क्या लेना है? Trigonal planar geometry लेना. Of course, the angle is 120. Why? Because since it's sp2 carbon, जो इसके साथ 3 sigma bonds बनेंगे, they are going to be planar. And above and below the plane will be having किसका electron cloud? The pi electron cloud. Fine. This is also very easy. The next thing we have over here is the polarity of the bond. Again very easy. Carbon oxygen bond हमेशा polarized होगा. क्यों? क्योंकि electronegativity difference है. Oxygen being more electronegative, उस पे del positive आएगा. Carbon पे del oxygen पे del negative आएगा. Carbon पे you'll have a del positive charge. Hence the carbonyl carbon is an electrophilic Lewis acid and carbonyl oxygen a nucleophilic center. This is important. What is a Lewis acid? Which can actually accept an electron pair, electron loving, electrophilic species. Fine. So Lewis acid electrophilic will be the carbon of the carbonyl group, and oxygen is electron rich, acts as a nucleophile. Lewis base can donate an electron pair. Carbonyl compounds have substantial dipole moments and are polar than the ethers. फाइन, ईथर से ज्यादा पोलर होते हैं. द हाई पोलैरिटी ऑफ द कार्बोनाइल ग्रुप इज एक्सप्लेन्ड ऑन द बेसिस ऑफ रेजोनेंस इन्वॉल्विंग अ न्यूट्रल and a dipolar structure as shown. Since there is resonance, there are resonating structures. You can see A and B. So resonance stabilized hai. As a result, polarity zyada hoga as compared to others. Right? Next up, we have preparation of aldehydes and ketones. Seems like a headache, but I think if you've done the basics or if you've done it like beforehand, kahin pe koi one shot dekha hai or whatever, or even if you've done it offline classes mein, I think just a reading of NCERT would be it and you're good to go. Fine. So moving on to the first preparation method, by oxidation of alcohols. Aldehydes, ketones generally prepared by oxidation of primary and secondary alcohols. Basically alcohols will have single bond OH. Fine. All you have to do is replace that by a C double bond O. So what all you have to do is, तो हम बेसिकली प्राइमरी अल्कोहल लेंगे, उसका ऑक्सीडेशन करेंगे इन प्रेजेंस ऑफ एन ऑक्सीडाइजिंग एजेंट और हमें एल्डिहाइड मिलेगा, और सेकेंडरी लेंगे तो फिर हमें कीटोन मिलेगा, अगेन इन प्रेजेंस ऑफ ऑक्सीडाइजिंग एजेंट्स. एक और मेथड है बाय डिहाइड्रोजनेशन ऑफ अल्कोहल्स. अगेन dehydrogenation और oxidation, I think it's pretty much the same, बस हम यहाँ पे reagents different use करते हैं. So this method is suitable for volatile alcohols and is of industrial application. Alcohol vapors are passed over heavy metal catalysts. Say Ag या हमने Cu ले लिया, silver, copper. Primary and secondary alcohols give aldehydes and ketones respectively. Again, basically dehydrogenation हो रहा है. So say you have something like just like this, you'll have your alcohol over here. डिहाइड्रोजनेशन करेंगे, सो यूल हैव हाइड्रोजन मॉलिक्यूल बाहर आ जाएगा और हमारे पास CH डबल बॉन्ड, दिस हाइड्रोजन कम्स आउट, CH डबल बॉन्ड O is created. Fine. This is just by the way for a better visualization. And the thing you have to remember, I think, is reagents. They would work wonders if you only remember the reagents. So here you have to use copper or 300 degrees Celsius पे, या फिर even you can take silver. Fine. Next is from hydrocarbons. अगेन इन केस ऑफ योर हाइड्रोकार्बन्स हमारे पास ओजोनोलिसिस होगा. एल्कीन्स का हमें पता है, जब भी ओजोनोलिसिस होता है इट कैन बी रिडक्टिव, इट कैन बी ऑक्सीडेटिव. रिडक्टिव वाले में सिंपली हैव टू रिमेंबर, रिडक्टिव वाले में जिंक ले लेते हैं, ऑक्सीडेटिव में जिंक नहीं लेते हैं. तो रिडक्टिव में हमें प्रोडक्ट के तौर पे एल्डिहाइड मिलता है और कीटोन मिलता है. बेसिकली हम जो हमारा C डबल बॉन्ड C तोड़ते हैं एल्कीन्स का, तो हमारे पास दोनों तरफ से ऑक्सीजन अटैच हो जाता है. सो वी विल गेट एन एल्डिहाइड, विल गेट अ कीटोन. सो अगर हम इसको ऑक्सीडेटिव ओजोनोलिसिस कराएंगे तो फर्दर ऑक्सीडेशन होगा और हमें क्या मिलेगा, एल्डिहाइड को अगेन ऑक्सीडाइज करेंगे तो कार्बोक्सिलिक एसिड बनेगा और कीटोन फर्दर ऑक्सीडाइज नहीं होता. द सेकंड वन हाइड्रोकार्बन से इज गिवन बाय हाइड्रेशन ऑफ एल्काइंस. तो हम हाइड्रेशन कहते हैं एडिशन ऑफ वाटर को, तो इथाइन को देंगे. अब यहाँ पे समथिंग यू हैव टू रिमेंबर इज, हम कौन से रिएजेंट्स यहाँ पे ले रहे हैं, तो हम ले रहे हैं यहाँ पे H2SO4, AgSO4. ये क्या देते हैं, दिल गिव यू एसिटल्डिहाइड. फाइन. बाकी सारे कीटोन्स, बाकी जितने भी अल्काइंस हैं, ठीक है, एक्सेप्ट फॉर इथाइन, दिल गिव यू कीटोन्स इन दिस रिएक्शन. तो सिर्फ हमें इथाइन के हाइड्रेशन से इन द प्रेजेंस ऑफ H2SO4, AgSO4, ठीक है, we will get acetaldehyde. Next is preparation of aldehydes. हम specially certain methods जिससे हम खाली aldehydes prepare करेंगे. पहला हमारे पास स्पेशल मेथड ऑफ प्रिपरेशन ऑफ एल्डिहाइड आता है रोजनमन रिएक्शन. तो रोजनमन में क्या होता है, बेसिकली हम जो है इसका रिडक्शन करते हैं, बिकॉज वी आर रिमूविंग मोर इलेक्ट्रोनेगेटिव एटम, दैट इज दिस Cl. फाइन. हमें क्या बनाना है, एल्डिहाइड बनाना है, CHO बनाना है. CO हमारे पास ऑलरेडी है, Cl को रिमूव कर दिया एंड वी आर गोइंग टू गेट CHO. इजी. हाउ डू वी डू दैट, हाइड्रोजनेशन. यहाँ पे कैटालिटिक हाइड्रोजनेशन लिया है इन द प्रेजेंस ऑफ H2PD. फाइन. और PSO4 क्यों लिया है, we have taken this as a poison to the catalyst so that extra oxidation से, वरना तो हमारा सीधे carboxylic acid बनेगा, but we have to stop the reaction. हमें aldehyde पर ही रुकना है, so we use BaSO4 as the poison to the catalyst. Fine. So if somebody asks why do we use BaSO4, this is basically a poison. Fine. And since we are doing reduction, अगर हम excessive reduction करेंगे हमें मिलेगा हमारे इससे एज अ प्रोडक्ट, एल्डिहाइड का और रिडक्शन करेंगे तो हमें अल्कोहल मिलता है. ठीक है, तो यहाँ पे अल्कोहल बन जाएगा अगर हम BaSO4 नहीं लेंगे. तो आई एम सॉरी इफ आई सेड कार्बोक्सिलिक एसिड्स प्रीवियसली, आई एम सो सॉरी फॉर दैट, प्लीज एक्सक्यूज दैट. बट बेसिकली फ्रॉम द एल्डिहाइड इफ यू रिड्यूस इट यू विल गेट अल्कोहल. देन वी हैव फ्रॉम नाइट्राइल्स एंड एस्टर्स. तो यहाँ पे हमारे पास स्टेफन्स रिएक्शन आता है. इन केस ऑफ स्टेफन्स रिएक्शन यू विल टेक योर नाइट्राइल. ठीक है, इसमें भी अगेन बेसिकली रिएजेंट याद रखना है, SnCl2 इन प्रेजेंस ऑफ HCl. फाइन. और ये हमारा नाइट्राइल हो गया, SnCl2 ले लिया इन प्रेजेंस ऑफ HCl, हमें मिलेगा RCH डबल बॉन्ड NH. फाइन. एंड देन दिस कैन बी रिप्लेस्ड बाय RCH2 एंड बाय प्रोडक्ट के तौर पे you'll get NH4Cl in presence of water. बाद में हम इसको हाइड्रोलाइज करते हैं, so I think water is also important. Yes, you'll remember it with this only. SnCl2 ले लिया, HCl ले लिया, water ले लिया. Wherever you see these reagents, हम directly aldehyde बनाएंगे from our nitrile. Fine. So this is your Stephen's reaction. Again, एक और हमारे पास method होता है double H वाला, which is given over here. So it says diisobutyl aluminium hydride. ये भी है. You can take your nitrile over here. Fine. Again, in presence of water, you'll again get an aldehyde only. Fine. So again, you can see over here, the same has been done. Only you have to remember the reagents and their functions. Especially if you're preparing for your NEET exam, you just have to just keep in mind, you whatever make a mnemonic code or whatever you want to do, just remember the reagents. Fine. So Stephen's reaction, RCN, SnCl2, HCl will give you aldehyde from nitriles. Fine. And you can also use diisobutyl aluminium hydride, that is diable H in presence of water. Again, nitrile को aldehyde में convert करने के लिए. अब esters again, diable H दे दो esters को, वो यही करेंगे. Diable H in presence of water, ठीक है, you are going to get an aldehyde and of course you'll also get an alcohol. Right? Diable H में हम क्या करते हैं basically, जो हमारा ester होता है, right? ये तो हमारा यहाँ पे बेसिकली ये है, ये पार्ट. फाइन. दिस विल कम आउट. यहाँ पे हमारा H अटैच हो जाएगा, तो ये आपका एल्डिहाइड बनेगा और इससे बेसिकली बाद में हमें अल्कोहल भी मिलेगा. फाइन. अब सिमिलरली हमारे पास है अरोमेटिक हाइड्रोकार्बन से हम कैसे बनाएंगे. फाइन. बेंजल्डिहाइड और उसके डेरिवेटिव से हम बेसिकली अरोमेटिक एल्डिहाइड्स कैसे अरोमेटिक हाइड्रोकार्बन से बना सकते हैं. सो दे हैव गिवन टॉल्विन दिया, ऑक्सीडेशन उसका करेंगे. यू हैव मिथाइल बेंजीन, वो हमारा टॉल्विन होता है. फाइन. तो यहाँ पे हमारे पास ईटाड रिएक्शन कम्स इनटू प्लेस, जहाँ पे हम क्रोमाइल क्लोराइड यूज करते हैं. फाइन. एक सूटेबल रिएजेंट लेना जरूरी है, क्योंकि मैंने आपको इससे पहले भी बोला कि हमें फर्दर रिड्यूस अगर नहीं कराना है इनटू अल्कोहल, प्रीवियसली आई टोल्ड यू, तो अगर हमें फर्स्ट ऑक्सीडाइज नहीं कराना है, हमें एल्डिहाइड पर ही रुकना है, हमें कार्बोक्सिलिक एसिड नहीं बनाना है, सो हम एक सूटेबल रिएजेंट लेते हैं जो बेसिकली बाद में इसको फर्दर ऑक्सीडाइज होने नहीं देता. सिमिलरली वी यूज हियर क्रोमाइल क्लोराइड. इट विल ऑक्सीडाइज द मिथाइल ग्रुप टू अ क्रोमियम कॉम्प्लेक्स व्हिच ऑन हाइड्रोलिसिस गिव्स कॉरेस्पॉन्डिंग बेंजल्डिहाइड. फाइन. तो इससे हमको मिलेगा हमारा बेंजल्डिहाइड. ये CH3 ग्रुप, इसको हम CH4 से रिप्लेस कर देंगे. फाइन. दिस इज हाउ वी डू इन केस ऑफ ईथार रिएक्शन. See, it's perfectly given over here in presence of a suitable solvent again. ठीक है, यहाँ पे आपका क्रोमियम कॉम्प्लेक्स बनेगा, इन प्रेजेंस ऑफ वाटर बेंजल्डिहाइड बनेगा. फाइन. और इसी को हम कहते हैं ईटार्ड रिएक्शन. Next, we have use of chromic oxide. Again, chromic oxide can also be used as an oxidizing agent. ये भी इस solvent को oxidize करके benzaldehyde बनाएगा. But difference is हम कोई retard reaction नहीं बोलेंगे. क्यों? क्योंकि हमने chromyl chloride नहीं लिया. Fine. Toluene or substituted toluene is converted to benzylidene diacetate. Fine. On treating with chromic oxide and acetic anhydride, the benzylidene diacetate can be hydrolyzed to corresponding benzaldehyde with aqueous acid. So this is some sort of a intermediate that will be formed. इसको benzylidene diacetate बोलते हैं. Fine. And इसको हम convert करेंगे in presence of heat and water into benzaldehyde. Fine. Then you have the next process, that is by side chain chlorination followed by hydrolysis. साइड चेन क्लोरिनेशन में क्या, जो हमारा साइड चेन है वो हमारा ऊपर मिथाइल ग्रुप है, उसके साथ हमने क्लोरिनेशन करनी है. तो CH3 विल कन्वर्ट इनटू CHCl2 इन प्रेजेंस ऑफ Cl2H. वी नो इट ऑलरेडी क्लोरिनेशन कैसे होता है. फाइन. और इससे हमें मिलेगा बेंजिल क्लोराइड. इसको बाद में हाइड्रोलाइज करेंगे और हमें बेंजिल डिहाइड मिलेगा. Another very important reaction is Bagattaman-Koch reaction. So when benzene or its derivative is treated with carbon monoxide, fine, again you have to remember the reagent in case of Gattam and Koch reaction. Fine. Carbon monoxide lena hai. You can remember Koch, CO. Fine. And hydrogen chloride, HCl, in the presence of anhydrous aluminium chloride, anhydrous AlCl3 or cuprous chloride, it gives benzaldehyde or substituted benzaldehyde. तो benzene ले लिया basically Gattam and Koch में. CO याद रखना है, कार्बन मोनोक्साइड, उसके साथ associated anhydrous AlCl3, HCl. ठीक है, उसको बाद में हमने इसके साथ treat करा लिया and you'll get benzaldehyde. Fine. And this is known as Gattam and Koch. Now coming about the preparation of ketones. अब ketones की क्या special methods है prepare करने के? So the first one given is from acyl chlorides. Acyl chloride हम basically पहले हम एक Grignard reagent लेते हैं अपना. We know that's RMgX. Fine. And we are making it to react with cadmium chloride. Fine. and what you get from here is dialkyl cadmium or apna MgXCl. If you want to go into the depths of the reaction, you can just simply write down RMgX would give you R minus, and then this will be plus and minus, simple reactions between plus and minus. That's really easy. But if you have to do things on a surface level, I think we shouldn't be going into those depths over here. So then again, this cadmium chloride, when you make it to react with your Grignard reagent, it'll give you ketones. Fine. Next up, we have from nitriles. Treating a nitrile with Grignard reagent followed by hydrolysis yields a ketone. Again, nitrile ले लिया हमने. Fine. This is a nitrile C triple bond N. और हमारे पास R M G X है, X B R है और R हमारे पास यहाँ C6H5 है. Fine. In presence of ether, हमें क्या मिलेगा? यहाँ पे अगेन यूल हैव प्लस माइनस. C जो है हमारे पास प्लस होने वाला है और एन जो है माइनस होने वाला है. अगेन ग्रिग्नार्ड से आर जो है वो माइनस आएगा, तो यहाँ इस सी के साथ हमारा आर ग्रुप अटैच हो जाएगा और जो प्लस वाला ग्रुप था वो एन माइनस के साथ अटैच हो जाएगा. दिस वाज एम जी एक्स विच वाज प्लस. फाइन. और बाद में इसको हाइड्रोलाइज करके you get your ketone. Fine. Then you have the next preparation method from benzene or substituted benzene. It's very easy. You simply do acylation reaction, जिसको हमने Friedel-Crafts acylation से पहले भी बहुत बारी पढ़ा है. Basically use anhydrous AlCl3 in every Friedel-Crafts reaction. Fine. Be it alkylation, acylation, we use anhydrous AlCl3 along with the reagent that we are using. So when benzene or substituted benzene is treated with acid chloride in the presence of anhydrous aluminium chloride, fine, it affords the corresponding ketone. This reaction is known as Friedel-Crafts acylation reaction. So you'll get a ketone from it because acyl group ऐसे attach हो जाएगा या हमारा alkyl group attach हो जाएगा कि हमें ketone मिलेगा. This is C double bond O containing group. Now, just wrapping up with the physical properties very, very quickly, just a reading would do, I think. So, the physical properties of aldehydes and ketones are described as follows. Methanol is a gas at room temperature, ethanol is a volatile liquid. Other aldehydes and ketones are liquid or solid at room temperature. The boiling points of aldehydes and ketones are higher than hydrocarbons and ethers of comparable molecular masses. And why is it so? Is due to weak molecular association in aldehydes and ketones arising out of the dipole-dipole interactions. Fine. Also, their boiling points are lower than those of alcohols of similar molecular masses due to absence of intermolecular hydrogen bonding. So, of course, हमारे पास जो थोड़े से similar masses के जो alcohols होंगे, उनका boiling point जो है वो कम होगा, वो ज़्यादा होगा aldehydes ketones से, because obviously there is intermolecular hydrogen bonding जो boiling point को बहुत rise कराता है. Fine. But aldehydes ketones का अपने mass के comparable जो उनके ethers या बाकी हाइड्रोकार्बन्स हैं उनसे ज़्यादा होगा because of weak molecular association in aldehydes and ketones. So molecule wise there is weak association, ठीक है, because there are dipole interactions. We know polar bond होता है C double bond O, so dipole interactions की वजह से you'll see their boiling points being higher than corresponding ethers, etc. Fine. Then it says the lower members of aldehydes and ketones such as methanol, ethanol, and propanone are miscible with water in odd proportions because they form hydrogen bond with water. अगर आप कम कार्बन वाले molecules ले रहे हैं वो miscible होते हैं पानी के साथ in odd proportions because उनका क्या हो जाएगा, hydrogen bonding होगा. However, why do we say that the solubility of aldehydes and ketones decrease rapidly on increasing the length of alkyl chain? This is all aldehydes and ketones are fairly soluble in organic solvents like benzene, ether, methanol, chloroform, etc. The lower aldehydes have sharp, pungent odors. As the size of the molecule increases, the odor becomes less pungent and more fragrant. In fact, many naturally occurring aldehydes and ketones are used in the blending of perfumes and flavoring agents. So this is because basically solubility तभी ज़्यादा होगा जब polar group ज़्यादा होगा, जब हमारा length of alkyl chain ज़्यादा हो जाता है. Eventually the part of the non-polar part, the hydrophobic part of the molecule, that increases. As a result, the solubility will decrease. Now about the chemical reactions of the same, since they both contain the similar functional group, that is a carbonyl group, so हम aldehydes or ketones का reactions will come under a similar topic. The first one is given nucleophilic addition reactions. Contrary to electrophilic addition observed in alkenes, the aldehydes and ketones undergo nucleophilic addition reactions. Why? Because they have a double bond. As a result, double bond पे addition होता है on the expense of the pi bond that is formed over here. So we'll have mechanism of the nucleophilic addition. A nucleophile, we know what is a nucleophile basically. a group that is electron rich, that can act as a Lewis base. Fine. This nucleophile will attack the electrophilic carbon atom of the polar carbonyl group from a direction approximately perpendicular to the plane of sp2 hybridized orbitals of carbonyl carbon. The hybridization of carbon changes from sp2 to sp3 in this process, and a tetrahedral alkoxide intermediate is produced. This intermediate captures a proton from the reaction medium to give the electrically neutral product. The net result is addition of nucleophile and proton across the carbon oxygen double bond as shown in the figure. तो बेसिकली क्या हो रहा है, न्यूक्लियोफाइल आ रहा है इन द फर्स्ट प्लेस. न्यूक्लियोफाइल आ ही क्यों रहा है? बिकॉज दिस पोलैरिटी, ऑक्सीजन पे डेल नेगेटिव है, कार्बन पे डेल पॉजिटिव है. As soon as the nucleophile comes, it will attack the कार्बन which has a slightly partial positive charge, और उस पर अटैक करने के बाद क्या बन रहा है, इसका जो sp2 है वो sp3 में कन्वर्ट हो रहा है. अभी 4 बॉन्ड्स बना रहा है, टेट्राहीड्रल स्ट्रक्चर. अर्लियर इट वाज अ प्लेनर स्ट्रक्चर, वी नो दैट ऑलरेडी. अब इस पे न्यूक्लियोफाइल है, ऑक्सीजन पे. अब सिंस यहाँ पे ऑक्सीजन पे नेगेटिव चार्ज आ रहा है, बिकॉज बॉन्ड जब टूटेगा तो यहाँ पे इलेक्ट्रॉन पेयर ऑक्सीजन लेगा, इलेक्ट्रोनेगेटिविटी डिफरेंस, और न्यूक्लियोफाइल कार्बन पे अटैच हो गया. ये ऑक्सीजन जो है न्यूट्रल बनाने के लिए प्रोटॉन एक्सेप्ट हो जाएगा और ये OH बनाएगा. फाइन. नाउ reactivity. Aldehydes are generally more reactive than ketones. In nucleophilic addition reactions, very important. Aldehydes ज़्यादा reactive होते हैं due to steric and electronic reasons. Steric hindrance जहाँ पे ज़्यादा होगा ना, ketones में ज़्यादा steric hindrance होता है, तो nucleophile को 10 दफ़ा सोचना पड़ेगा कि मुझे किस साइड पे अटैक करना है. Aldehydes में that's not the case. You'll have terminal functional group. So you'll have a hydrogen on one side. Easily the nucleophile can attack. Sterically, the presence of two relatively large substituents in ketones, यही ये कह रहा है, hinders the approach of nucleophile to carbonyl carbon than in aldehydes having only one such substituent. Electronically, aldehydes are more reactive than ketones because two alkyl groups reduce the electrophilicity of the carbonyl carbon more effectively than in former. क्योंकि अल्काइल ग्रुप्स प्लस आई ग्रुप्स होते हैं, वो इलेक्ट्रोफिलिसिटी को कम करते हैं, यानी जो पॉजिटिव चार्ज है ना कार्बन पे उसको कम करते हैं, बिकॉज जब इलेक्ट्रॉन डोनेटिंग ग्रुप्स अटैच्ड होते हैं तो उसका इलेक्ट्रॉन डेंसिटी इंक्रीज हो जाता है. इसी mechanism पे there are certain important examples of nucleophilic addition and nucleophilic addition elimination reactions. Fine. Addition of hydrogen cyanide, HCN. Aldehydes and ketones react with hydrogen cyanide to yield cyanohydrins. As you can see, यहाँ पे cyanohydrin है हमारा, ये हमारा carbonyl group हो गया aldehyde ketone का, ये हमारा cyanide हो गया. Fine. Cyanide पे CN negative, ये nucleophile है, इसके पास electron pair है, और ये अटैच होगा हमारे डेल पॉजिटिव वाले कार्बन के साथ. फाइन. सो यू विल गेट अ टेट्राहीड्रल इंटरमीडिएट, जिसमें फिर बाद में this O will also be surrounded by a proton, fine, to yield a neutral product. This reaction occurs very slowly with pure HCN, therefore it's catalyzed by a base and generated cyanide. Being a stronger nucleophile readily adds to carbonyl compounds to yield corresponding cyanohydrins, a very useful synthetic intermediate. So that's all it says. You need to have a base. से यहाँ पे कोई भी आप यहाँ पे स्ट्रॉन्ग बेस ले लेंगे, एज अ रिजल्ट जो आपका रिएक्शन है वो कैटलाइज हो जाएगा. फाइन. एडिशन ऑफ सोडियम हाइड्रोजन सल्फाइड. फाइन. Sodium hydrogen sulfide adds to the aldehydes and ketones to form the addition products. Very easy. Again, NaHCO3, this is sodium hydrogen sulfide. ठीक. और ये आपका कार्बोनाइल ग्रुप हो गया. फाइन. ये होगा अटैच विद द C पॉजिटिव. ये है हमारा न्यूक्लियोफाइल. फाइन. OSO, ये जो हमारा है ना SO3H, that will be the nucleophile. Fine. Na positive will be the इलेक्ट्रोफाइल. फाइन. और इलेक्ट्रोफाइल हमारे नेगेटिव के साथ O नेगेटिव के साथ अटैच होगा, और जो हमारा HSO3 है दैट विल बी द नेगेटिव पार्ट. फाइन. Sodium hydrogen sulfide adds to aldehydes and ketones to form the addition products. The position of the equilibrium lies largely to the right hand side for most aldehydes and to the left for most ketones due to steric reasons. Again, इसमें सारा स्टीरियोकेमिस्ट्री आता है. The hydrogen sulfide addition compound is water soluble, and can be converted back to the original carbonyl compound by treating it with dilute mineral acid or alkali. Therefore, they're useful for separation and purification of aldehydes. So what all you can do is this hydrogen sulfide, it can be this compound, it's water soluble, और हम इसको वापस convert करेंगे to the original carbonyl compound में by using mineral acids or bases. ठीक. and इसी तरह हम purification separation करते हैं aldehydes की. Fine. And about this paragraph right here, ये यही बताने की कोशिश कर रहा है कि aldehydes में steric hindrance कम होता है, तो right side पे largely the equilibrium will be shifted towards the right side. Fine. और हमारे पास left side की ओर this equilibrium. Fine. तो steric reasons की वजह से ये सब होता है. Fine. नेक्स्ट अप वी हैव एडिशन ऑफ Grignard's reagent. ये कह रहा है refer to unit 11 जो हम ऑलरेडी कर चुके हैं. Again, that is also a nucleophilic addition. RMGX will yield R negative, which can act as a nucleophile. Again, it will get attached to this, और फिर हमारा tetrahedral structure बनेगा. Then you have addition of alcohols. Aldehydes react with one equivalent of monohydric alcohol in the presence of dry hydrogen chloride to yield alkoxy alcohol intermediate known as hemiacetal, which further reacts with one or with one more molecule of alcohol to give a gem dialkoxy compound known as acetal as shown in the reaction. Basically, you take your aldehyde, fine, you take your alcohol in the presence of some acid, HCl gas ले लिया यहाँ पे dry hydrogen chloride, fine, you will get something that is hemiacetal. Hemiacetal में ये हमारा एक alkoxy intermediate है, सी ओ आर सी एच ओ आर, दिस इज एन alkoxy intermediate, और इसको बाद में और हम फर्दर अल्कोहल मॉलिक्यूल के साथ रिएक्ट कराएंगे अगेन विद वन मोर मॉलिक्यूल अगेन इन द प्रेजेंस ऑफ H पॉजिटिव, और जो ये OH है ये भी रिप्लेस हो जाएगा OR से, एंड दिस स्ट्रक्चर इज नोन एज एसिटल. कीटोन्स रिएक्ट विद एथिलीन. कीटोन्स के साथ भी कुछ सिमिलर होता है. एथिलीन ग्लाइकॉल, एथिलीन ग्लाइकॉल इज दिस इज अ vicinal diol, fine, under similar conditions to form cyclic products known as ethylene glycol ketals. अब यहाँ पे हमारे पास कीटल बनेगा, ठीक है. दिस इज cyclic product, fine, this is our C. ठीक, इसके साथ O और O2 इस तरह अटैच हो जाएंगे और उनके साथ इस तरह हमारे CH2, ये जो हमारा ग्लाइकॉल है बेसिकली ये इस तरह से दोनों तरफ ऐड हो जाएगा हमारे कार्बन के साथ, एंड दिस इज अ कीटल एंड दिस इज अ साइक्लिक प्रोडक्ट. Dihydrogen fluoride protonates the oxygen of the carbonyl compounds and therefore increases the electrophilicity of the carbonyl carbon, facilitating the nucleophilic attack of ethylene glycol. बेसिकली जो प्रोटॉन जब ऐड हो जाएगा, प्रोटोनेट हो जाएगा हमारा ऑक्सीजन कार्बोनाइल कंपाउंड का, तो उसकी इलेक्ट्रोफिलिसिटी बढ़ेगी इन द सेंस कि उसका टेंडेंसी एफिनिटी टुवर्ड्स इलेक्ट्रॉन विल बी मोर, फाइन. Also, हमारे जो acetals और ketals हैं, again we can hydrolyze them with aqueous mineral acids and they'll give you back the corresponding aldehydes and ketones respectively. Next, we have addition of ammonia and its derivatives. NH2Z, basically ammonia NH3 होता है, तो अगर आपने एक हाइड्रोजन को हटा के कोई भी और ग्रुप लगा दिया, H can, Z can be anything, यहाँ दिया हुआ है alkyl, aryl, OH, NH2, etc. Right? So that is ammonia derivative. They add to the carbonyl group of aldehydes and ketones. Again, addition reaction. Reaction is reversible and catalyzed by an acid. Reversible है तो दम नहीं है, मतलब reaction we need to catalyze the reaction. The equilibrium favors the product formation due to rapid dehydration of the intermediate to form this. ये जो यहाँ पर दिया हुआ है dehydrate हो रहा है, ठीक है. Dehydration से forward equilibrium is favored more. Again, there are some nitrogen substituted derivatives of aldehydes and ketones. So basically Z को हमने different group से replace किया है, और ये जिनका names you have ammonia, अगर H से replace करोगे you can have amine, hydroxylamine, hydrazine, NH2 very important, phenyl hydrazine, हाँ, NH2 के साथ NH और अपना phenyl group, then 2,4-dinitro, phenyl hydrazine and सेमी कार्बोजाइड वगैरह, ठीक, यहाँ पे हम देख सकते हैं. एंड व्हाट आर द कार्बोनिल डेरिवेटिव्स? All of these are the carbonyl derivatives and the product name. Fine, imines and substituted imine, Schiff base, oxime, hydrazone, phenyl hydrazone. Basically, you can carry out the reactions. Addition ही करना है, fine, और फिर वो हमारा tetrahedral product बनता जाएगा. Fine. Now, moving on to reduction. Reduction reactions भी होते हैं. Reduction to alcohols, aldehydes, ketones are reduced to primary and secondary alcohols respectively by sodium borohydrate, NaBH4, reducing agent, very good reducing agent, lithium aluminium hydride, as well as by catalytic hydrogenation. Reducing agent ले लिया, basically वो क्या करेगा, aldehyde और ketone को alcohol में reduce करेगा. Then reduction to hydrocarbons, carbonyl group of aldehydes and ketones is reduced to CH2 group on treatment with zinc, amalgam and concentrated hydrochloric acid. This is Clemenson reduction. Again एक और name reaction है, आपको इसमें क्या याद रखना है, you have to remember the reagent and its functions. You will take zinc amalgam मतलब इसका आप mercury के साथ इसका fused compound ले रहे हैं और हमारा in the presence of HCl. This is Clemenson reduction, और इसमें और even with hydrazine followed by heating with sodium or potassium hydroxide and high boiling solvents such as ethylene glycol, जिसको हम Wolff-Kishner reduction बोलते हैं. Again, hydrazine ले लिया, NH2, fine, you'll heat it with पोटेशियम हाइड्रोक्साइड इन बॉइलिंग सॉल्वेंट से, यहाँ पे इथाइलिन ग्लाइकॉल लिया है, ठीक है, इसको हम वुल्फ किश्नर रिडक्शन बोलते हैं। बेसिकली हमने सी डबल बॉन्ड ओ जो है उसको हमने CH2 में कन्वर्ट किया, हमने अपने एल्डिहाइड कीटोन को हमने एल्केन्स में कन्वर्ट किया। इज इट क्लियर? यस। Next we have oxidation. Aldehydes differ from ketones in their oxidation reactions. अब क्या फर्क आ रहा है? Aldehydes are easily oxidized to carboxylic acids on treatment with common oxidizing agents like nitric acid, potassium permanganate, potassium dichromate, etc. Even mild oxidizing agents, mainly Tollens reagents, some mild Fellings reagent, they can also oxidize aldehydes. But aldehydes normally बहुत, तो सिंपली हम ऑक्सीडाइज करें एल्डिहाइड्स को और वो इजीली ऑक्सीडाइज हो जाते हैं। तो माइल्ड ऑक्सीडाइजिंग एजेंट्स, टॉलेंस, फेलिंग्स रिएजेंट, ये भी ऑक्सीडाइज कर सकते हैं और फिर इवेंचुअली हमारे कार्बोक्सिलिक एसिड्स मिलते हैं। कीटोन्स आर जनरली ऑक्सीडाइज्ड अंडर विगरस कंडीशंस, दैट इज स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट्स एंड एट एलिवेटेड टेम्परेचर्स. Their oxidation involves carbon-carbon bond cleavage to afford a mixture of carboxylic acids having lesser number of carbon atoms than the parent ketone. तो यहाँ पे बेसिकली कीटोन्स में हम देखते हैं कार्बन कार्बन बॉन्ड को टूटना है और इसीलिए वो थोड़ा ज़्यादा विगरस कंडीशंस में होगा, टेम्परेचर ज़्यादा चाहिए, स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट्स चाहिए और हमें क्या मिलता है? विल गेट अ मिक्सचर ऑफ कार्बोक्सिलिक एसिड्स हैविंग लेसर नंबर ऑफ कार्बन्स. The mild oxidizing agents given below are used to distinguish aldehydes from ketones. तो हमारे पास ये टेस्ट आते हैं, हम प्रैक्टिकल्स में भी करते हैं यूजुअली. So the first one is tolerance test on warming an aldehyde with freshly prepared ammonical silver nitrate solution, which is the tolerance reagent. Again, you have to remember this. Memory based होती है बहुत चीज़ें केमिस्ट्री में. A bright silver mirror is produced. तो इसलिए हम इसको silver mirror test भी बोलते हैं. Due to the formation of silver metal, the aldehydes are oxidized to corresponding carboxylate ion. The reaction occurs in an alkaline medium. So you take an aldehyde, you take ammonical silver nitrate, ठीक, और बेसिक मीडियम ले लिया तो हमारे पास कुछ ऐसा मिल जाता है, कार्बोक्सिलेट आयन मिल जाता है. फाइन. which will result in the formation of a silver metal and mirror formation हो जाएगा. Fine, because silvering हो जाएगा test tube का, and that can be indicative of a presence of the aldehyde. Then you have Fehling's test. Fehling reagent में दो solutions होते हैं, Fehling solution A and Fehling solution B. Fehling solution A is aqueous copper sulfate. Aqueous copper sulfate, and Fehling solution B is alkaline sodium potassium tartarate, which is also known as the Rockhill salt. Fine. So you can have aqueous copper sulfate, वो हमारा solution A होगा, और Fehling solution B है हमारा alkaline sodium potassium tartarate, जिसको Rockhill salt भी बोलते हैं. इन दो solutions को equal amounts में लेते हैं before the test. On heating an aldehyde with Felling's reagent, a reddish-brown precipitate is obtained. Aldehydes are oxidized to corresponding carboxylate ion. Anion, aromatic aldehydes do not respond to this. The Felling test does not stand for aromatic aldehydes. Fine. Moving on, we have oxidation of methyl ketones by haloform reaction. Again, in this type of reaction, the methyl group of a methyl ketone, it is converted to a haloform such as iodoform, और जो हमारा carbonyl carbon होता है, it is oxidized to a carboxylic acid. So this like the simpler terms. अब हम देखते हैं complexity में NCERT ने क्या लिखा है. Aldehydes and ketones having at least one methyl group linked to the carbonyl carbon atom are oxidized by sodium hypohalite to sodium salts of corresponding carboxylic acids having one carbon atom less than that of carbonyl compound. The methyl group is converted to haloform. This oxidation does not affect a carbon-carbon double bond if present in the molecule. So iodoform reaction with sodium hypoiodide is also used for detection of CH3CO group or CH3CHOH group, which produces CH3CO group on oxidation. So basically क्या होगा, methyl group जो है methyl ketone का उसको convert करेंगे haloform में जैसे iodoform, और जो carbonyl carbon होगा उसको oxidize करेंगे into a carboxylic acid. Next up is reactions due to alpha hydrogen. अब alpha hydrogens जो है acidity सबसे पहले उसका discuss किया गया है. Fine. The aldehydes and ketones undergo a number of reactions due to the acidic nature of alpha hydrogen. Alpha hydrogen present होता है, उसके acidic nature की वजह से क्या होता है, बहुत सारे reactions. The acidity of alpha hydrogen of carbonyl compounds is due to the strong electron withdrawing effect of the carbonyl group and resonance stabilization of the conjugate base. So what happens here basically? Resonance stabilization तो है ही, हमें पता है carbonyl group में, और क्या होता है यहाँ पे, you can see इलेक्ट्रॉन विड्रॉइंग इफेक्ट होता है कार्बोनाइल ग्रुप का. फाइन, इलेक्ट्रॉन विड्रॉइंग इफेक्ट, और इसकी वजह से जब इलेक्ट्रॉन को अपनी ओर खींचेगा acidity easier, the release of proton becomes easier. So but you need to have an alpha hydrogen for that as a condition. तो इसमें पहला है aldol condensation, aldehydes and ketones having at least one alpha hydrogen. ठीक है, aldol condensation में alpha hydrogen होना चाहिए. अभी हम canis arrow देखेंगे, there you do not need to have an alpha hydrogen. Now aldol में at least one alpha hydrogen undergo a reaction in the presence of dilute alkali as catalyst to form beta hydroxyaldehydes, aldol, or beta hydroxyketones, ketol, respectively. This is known as aldol reaction. बेसिकली इस रिएक्शन के मैकेनिज्म में क्या होता है, पहले एक कार्बन आयन हमारा बनता है, ठीक है, कार्बन कंटेनिंग नेगेटिव चार्ज, और फिर उस कार्बन आयन पे ये जो है इट इज गोइंग टू अटैक अदर एल्डिहाइड्स और कीटोन्स. फाइन. सो अगेन इट कैन बी सेल्फ और सिंपल एल्डोल, इट कैन बी मिक्स्ड और क्रॉस एल्डोल डिपेंडिंग अपॉन हम जो एल्डिहाइड्स ले रहे हैं वो हम सिमिलर ले रहे हैं या फिर हम डिफरेंट ले रहे हैं. फाइन. And this will be carried out in presence of a base, dilute NaOH, which will give you OH negative ions. अब उस OH negative से क्या होगा बेसिकली, वो हमारे अल्फा हाइड्रोजन पे अटैक करेगा. फाइन. और दैट विल फॉर्म अ कार्बन आयन. ठीक. और वो कार्बन आयन जो है बाद में it is going to attack on another, either a similar or a different aldehyde, and eventually what will happen, उस aldehyde में भी जिस पे ये attack करेगा, that will also have a del positive on the carbon of the carbonyl group, and eventually you will see uh, due to the presence of this positive and negative, they're going to attach and we'll get something as a different product. Again, you are given ethanol over here. ठीक है, इसको dilute NaOH के presence में, we know base के presence में क्या होता है, OH negative मिलेगा, और हमारा जो है, they're not showing actually the mechanism, they're not showing the carbon ion formation, they're simply showing फिर eventually हमारे पास aldol बन जाता है hydroxy group attach होने के बाद. उसका बाद में dehydration कराया है and you get the aldol condensation products. Fine. The name aldol is derived from the names of the two functional groups aldehyde and alcohol present in the product. So whatever you get as products is aldehyde and it's alcohol. So इसीलिए aldol is the name. Aldol and ketol readily lose water to give alpha beta unsaturated carbonyl compounds which are aldol condensation products, and the reaction is called aldol condensation. Though ketones give ketols, compounds containing a keto and an alcohol group. ठीक है, वो ketols देंगे जहाँ पे keto और alcohol होगा. The general name aldol condensation still applies to the reactions of ketones due to their similarity with aldehydes. Coming to cross aldol condensation. Cross, again we know when aldol condensation is carried out between two different aldehydes or ketones, it is cross aldol condensation. If both of them contain alpha hydrogen atoms, it gives a mixture of four products. ठीक है, तो पहले जो हमने दो डिफरेंट लिए, चार प्रोडक्ट्स कैसे मिलेंगे, इसका अपने साथ सेल्फ, इसका अपने साथ सेल्फ, इसका इसके साथ क्रॉस, और इस वाले का इसके साथ क्रॉस. सो यू विल गेट फोर प्रोडक्ट्स. सिमिलर हमने कंडीशंस ले लिए, वी टुक अ बेस. फाइन. एंड दैट्स हाउ you can get the four different products. Simple or self products होंगे, और हमारे पास होंगे cross aldol products as well. Ketones can also be used as one component in the cross aldol reactions. Then you have other reactions में canis arrow है, aldehydes which do not have an alpha hydrogen atom, they will undergo self oxidation and reduction. Disproportionation reactions कौन सी होती हैं, जिनमें oxidation reduction simultaneously एक ही reaction में होते हैं. तो canis arrow भी basically aldehydes खुद से disproportionation reaction they show on heating with concentrated alkali. यहाँ पे concentrated base लेंगे, aldol में हमने लिया था dilute base. In this reaction, one molecule of the aldehyde is reduced to alcohol while another is oxidized to carboxylic acid salt. Very easy. aldehyde को reduce करेंगे तो alcohol मिलेगा, aldehyde को oxidize करेंगे तो carboxylic acid मिलेगा. So eventually हम देखेंगे कि अगर disprop हो रहा है, एक तो हमारे पास alcohol मिलेगा और हमारे पास carboxylic acid मिलेगा. Fine. सिंस फिर यहाँ पे हमारे पास बेस होती है, तो उस कार्बोक्सिलिक एसिड का सॉल्ट बन के आता है हमारे पास. फाइन. So the third one over here is electrophilic substitution. Aromatic aldehydes, हमें already पता है benzene ring में addition वगैरह नहीं होता है. What we have over there is electrophilic substitution. Fine. Aromatic aldehydes and ketones undergo electrophilic substitution at the ring in which the carbonyl group acts as a deactivating and meta-directing group. Deactivating groups are meta-directing groups. We already know that. So whenever you have a carbonyl group attached to the benzene, आप समझ जाएंगे कि meta पे हमारा coming electrophile is going to attach because carbonyl group is a meta-directing group. Let's come to the uses of aldehydes and ketones. In chemical industry, aldehydes and ketones are used as solvents, starting materials, and reagents for the synthesis of other products. Formaldehyde is well known as formalin, 40% solution, used to preserve biological specimens and to prepare bakelite of phenol formaldehyde resin. हम bakelite polymers में भी देखते हैं urea formaldehyde glues, and other polymeric products. Fine. फॉर्मेलिन में बेसिकली वी प्रिजर्व वेरियस स्पेसिमेंस बायोलॉजिकल लैब में आपने देखा होगा acetaldehyde is used primarily as a starting material in the manufacture of acetic acid, ethyl acetate, vinyl acetate, polymers, and drugs. Benzaldehyde is used in perfumery. It's aromatic. And in dye industries, acetone and ethyl methyl ketone are common industrial solvents. Many aldehydes and ketones, example butyraldehyde, vanillin, acetophenone, camphor, etc., are well known for their odors and flavors, जो हमने beginning में ही किया था. So I think that's it for this lecture. We'll be discussing carboxylic acids in the very next lesson. So I just hope it was helpful to you, and you just this can be sort of an NCRT highlight along with a little more information wherever it's needed. Just make sure you're done with your basics and then you go through this video. I think this is going to be really helpful for you. So thank you all for watching.